Hey everybody, it's Dr. Doyle, and I am here to present the companion video for the Lesson 14 activity. This video is partly a demo, and so you're not going to be able to see my face for the entire duration of that demo, so I just wanted to pop on and say hello and encourage you to please follow along in your lesson sheet as I go through the solving of the free body diagrams and then the physical demo. You're going to get much more out of it this way than if you just watch the video without following along. Okay, so good luck, and I'll see you soon. Bye. So as I mentioned, we're going to be following along the steps of the activity, and I'm going to insert places for you to pause the video and do what the lesson sheet says before you continue on. So the first thing is that this activity, step 1, so it's to draw a free body diagram for the following system. We'll do this one together. So I'm going to draw a free body diagram for the following system, and I will go ahead and do it down over here. So I'm just going to draw a representation here for my beam, and that's going to be a total of 12 inches. So I have 6 inches and then 6 inches, and then I'm going to draw my forces on there. So I'm going to have 10 grams. Of course, grams is not a force, but we're just going to use it as a surrogate for force in this activity for convenience, and you'll see why in a minute when I show the demonstration. And then we can, if these are both, if A is a pin, we would have AY and AX, and then B is a roller, so we would have BY. So there's the free body diagram for this system shown. Part B here asks us if we can guess the value of AX and give our result in grams. So instead of guessing, I'm just going to write the equation of equilibrium here. We have the sum of the forces X need to sum to 0. I'm going to say to the right-hand side is positive. Well, we see that the only force acting in the X direction is AX. So, of course, this means that AX is 0. And what this is going to allow us to do is when I do the demonstration, we are going to be using 2 roller type supports rather than a roller and a pin. And then we can guess the value for AY and BY. So I'm going to go ahead and let you take a guess at what you think AY and BY would be, and then I will show you what happens in here. I'm going to turn them both on, and then I have my 2 half dowels, which I'm going to place as close to the center of these scales as possible. So you can see they're both currently showing 0 grams because when I turn them on, the dowel's already on them. Then I'm going to take my wooden ruler, place it right on top, and I may need to move this one over a little bit. Okay, so I'm going to scooch this whole thing over so you can see it. There we go. So, okay, so there we have it centered. Now I'm going to tear both of these so that they both will read 0. All right, so we have, if you're following along, this is A, and on the right-hand side is B. So I'm going to start first by taking a 10 gram mass and placing it right in the middle. And so you should have already attempted to draw the free body diagram of this scenario and solve for AY and BY using equations of equilibrium. And so we're just going to see if we were right in our calculations. So right in the center here, I'm going to put my 10 grams. And it looks like there we go. Oh, I was there a second ago. And of course, we're not going to be exact, but we have the left-hand side, A, reading 4.9 grams, and the right-hand side, or B, reading 5.0 grams. So we're about there, right? It's 5 grams on each side, which we did show when we did the free body diagram and solved for the equations of equilibrium. So the next part asks you to attempt to solve the equations of equilibrium if the 10 gram mass is 3 inches from A. And so let's see and compare if your answers are correct. And so I'm going to place this 10-gram mass at 3 inches from the edge. And when I do that, you see that AY, which is shown on the left-hand side here, reads 7.5 grams, and then 2.5 grams BY on the right-hand side, which sums up, yay, to 10 grams. Okay, and that was number 4. Now you have tried this next step where I am going to take 2 5-gram weights. So 5 grams and 5 grams. Of course, that sums up to 10 grams. And I'm going to start first by taking that 5-gram weight and putting it 4 inches from AY. Sorry for that noise. I did not time my video making very well to my laundry today. So that's my washing machine. Hopefully it's not too distracting. And if you do that, you are going to see that on the left-hand side, I get 3.3 grams, and on the right-hand side, I have 1.7 grams. Those do sum up together to be 5 grams, which is just what we would hope. And so hopefully, if you were able to derive the geometric relationship, you already showed yourself that this was going to be the solution. Now I'm going to move my 5-gram mass 2 inches from A, so it's going to show up right about here. And when I do that, I get about 4.1 grams on the left-hand side, 0.9 grams for BY on the right-hand side. Again, that sums up to a total of 5 grams. Now I'm going to take a second 5-gram mass, and I'm going to put it back where the original one was at 5 grams. And when we do this, I get 7.4 grams on the left-hand side, 2.6 grams on the right-hand side. So I want you to compare this. If you're following along in your handout, this is 5E. And compare this to the answer we got when I put the 10-gram weight 3 inches from the middle. So again, that led us to 7.5 for AY and 2.5 for BY. So I've taken that 10 grams and I've spread it out a little bit, but I get the same answer. So we're just thinking about what that might mean for us in terms of our engineering statics design. Last one I'm going to do is I'm going to take 10 1-gram weights. I'm actually going to separate them into 5 piles of 2. So that one has 3. And I am going to place them so that the middle one is right at 9 inches. And then I'm just going to load them up. Did I skip? Oh, that one has 3. That's not going to work. Make sure these are all nice and centered. And then very similar to our other results, on AY would equal 7.4 grams and BY would equal 2.6 grams. So go back to your handout now and try to draw a free body diagram for this beam and ask yourself how many forces would you have to include if you sum the moments about point A. What's the total weight we applied here, and where's the center of mass for the total weight? Number 8 asks us to try and redistribute this so that we create a triangle. So I'm going to make the last one, number 8. I want you to go ahead and think about this on paper on your own, and we'll look at it in class together, but I'm going to refrain from showing this demo here so you can think about this triangle-shaped distribution on your own. We'll see you in class soon.